Write an equation in general form for the third degree polynomial with zeros, -4, 2i, -2i, and a y-intercept of 2.
Okay. What are the three factors of this polynomial?
X plus 4, x minus 2i, x plus 2i.
And there is some constant, a.
Mm-hmm.
So my polynomial is going to be that. And we're going to figure out a by figuring out what value of a will produce a y-intercept of 2.
Okay.
Which of these two should we multiply together first?
The x plus 2i, x minus 2i.
Okay. That looks like difference of perfect squares. So what is that equal to?
Hang on 1 second.
Now, one of the advantages of recognizing it as difference of perfect squares is I know that it has to be this. There's your difference of perfect squares. If I gave you this to start with, you would factor it this way.
Okay.
Okay, what's I squared equal to?
-1.
So this becomes x plus 4. Multiply that by another x plus 4. Go ahead and multiply that term by term.
X cubed minus 4x plus 4x squared.
So I think everything's plus, is it not?
It is.
If a were 1, what would my y-intercept be?
2.
Pardon?
2.
No, if a were not there, in other words, if this were our polynomial, what's the y-intercept?
2.
Well, it's 16 here. Okay? In other words, without a multiplier, it would be 16. So what does a need to be?
8.
Well, not 8, but how about 1 over 8? In
Okay.
other words, if I make a 1/8, now I produce this polynomial. Right? Here, let's put it in proper order. In other words, we need to multiply this polynomial by whatever constant is required to make this a 2. Correct? In other words, they told us that the y-intercept was 2. Well, if I took just the polynomial that I got by multiplying the three factors, I get a y-intercept of 16. With me? I don't feel like you're understanding this.
No, not really.
Okay. Remember that the standard format is this. If you give me the 3 zeros, then I can create three linear factors, 1, 2, 3, and know that the polynomial is going to be some constant times those three factors. In other words, this is kind of like my general formula for these three zeros. So after I multiply that by that by that, I get this polynomial. Well, what's wrong with that polynomial? That polynomial has the three zeros that we're talking about. But its y-intercept is 16. So if I multiply it by an a of 1/8, it will then have, in other words, if I look at the equation below, at the very bottom of my page, what's the y-intercept?
2.
Correct.
Okay.
If they would have said, give me a y-intercept of 48, what would A have to be?
You'd have to multiply 16 by 3.
Correct. So if they would have said the y-intercept is 48, then that's going to be the polynomial. After I multiply 3 times everything.
Okay.
Okay, so you have to make A be whatever fits their condition. And it won't always be a y-intercept. They could have said, give me a polynomial that has 1/8 as the coefficient of the x cubed term. And I would have had to do the same thing. I would have gotten to here and realized, well, my coefficient is 1, so I need to multiply everything by 1/8.
Okay, that makes more sense. Okay. Explain how the leading coefficient and the degree are used to describe the end behavior.
To describe the what?
Describe the end behavior.
Okay. Read the question again one more time, please.
Explain how the leading coefficient and the degree are used to describe the end behavior.
Okay. The only thing that affects the end behavior, the highest degree polynomial. Okay. In other words, I don't care about this. I don't care about that. This will tell me the end behavior. In this case, it's a parabola like that. What's the end behavior? X goes to
as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to infinity.
Okay. When they say explain how the coefficients, what they really mean is whether it's positive or negative. In other words, if I put a 3 in front of that, it does not affect the end behavior at all.
It doesn't?
No. In other words, all I now have is a parabola that's a little skinnier. Okay? However, what would affect the end behavior is if I put a negative 3. In other words, if I put a negative, it reflects over the x-axis. Now the end behavior is completely different. Now it goes to negative infinity in both directions. So it's really the sign of the highest degree polynomial that's important. And let's look at a different one. Let's look at x cubed. Well, the way I would graph x cubed is like this. Okay, so the end behavior is plus infinity to plus infinity, negative infinity to negative infinity. And if I put a 2 on that, it doesn't change anything. But if I put a negative sign there, it flips it over the x-axis so that it looks like this, and that does change the end behavior. So the sign is what affects the end behavior, not the coefficient, although I guess you could call that the coefficient. But it's misleading a little bit to say explain how the coefficient changes the end behavior. It's the sign of the coefficient. And as far as any other term, it does not matter. I can have 10,000 x squareds that I'm adding to that, or 100,000. And the only thing that affects end behavior is that leading term. None of the rest of it do.
So basically, the leading coefficient doesn't change the end behavior. The signs do, and the degree changes the end behavior by showing.
If the degree is even, let's say it's this, then the thing looks like that. Okay, so the degree, if it's odd, then the thing looks like this. If it's negative even, it looks like that. If it's negative odd, it's a reflection of that. So I hate math questions that say explain. They're not really fair. Math should be give an answer to a problem, and that's it. Because the moment they say explain, that means some teacher is going to subjectively analyze your answer. So I don't know how to tell you exactly how to explain it. I've explained it as best as I know. It's only the highest degree that affects the end behavior, and the sign on the highest degree affects the end behavior also, not the size of the coefficient.
Okay. Give an example of a function that is odd as an equation in graph. Give an example of a function that is even as an equation in graph. Give an example of a function that is neither as an equation in graph.
Okay, odd means it's all about what is f of negative x. That's what they're talking about. Okay, so odd functions, f of negative x is always negative f of x. And an example of that would be y equal x cubed. Well, I shouldn't even use y. Let's say f of x. F of x and y are interchangeable, but if f of x is equal to x cubed, then f of negative x would be equal to negative x cubed, which is equal to negative f of x. Okay, so here's the property along the top. Even functions, f of negative x is equal to f of x. An example of that would be x squared. notice that f of negative x, if the function is x squared, f of negative x is still x squared. It does not turn into a negative. And neither would be where neither of these is true. In other words, f of negative x would not equal negative f of x, nor would it equal f of x. An example of that function notice what f of negative x is. Still x squared minus x. Okay? This is neither negative f of x, nor is it f of x.
Okay.
Okay? So those are your three functions. That's an odd function. That's an even function. And this one is neither. And
Okay.
it's all entirely based on what f of negative x is.
Okay.
Okay? Have you had trig yet?
No.
There's one other thing let me say about odd and even functions. Remember that's x squared, which is even. One way to remember that is if it has an even exponent, it's an even function. And the other thing is that even functions are symmetrical about the y-axis. In other words, every even function that I can come up with, if you flip it, reflect it about the y-axis, it looks exactly the same. Odd functions are symmetrical about the origin, not a particular axis. In other words, if I put my odd function there, which is y equals x cubed, that's odd. And notice that it's not symmetrical about the either axis, but it is symmetrical about the origin. If I flip this thing about the y-axis and then again about the x-axis, you get the same thing. So this is what symmetry about the origin looks like. Particularly easy to tell with trig functions because sine is odd and cosine is even. But go ahead. What's your next
one? That's all I had for today.
Okay. Your test is probably next Wednesday or Thursday?
Thursday.
Thursday, okay. So she doles out this review. I've been finding that with a couple of students that I've ended early with. It's unfortunate. It would work better if they gave you all 5 sheets of your review material.
Yeah.
So that we could go until we finish with, 30 minutes. Okay. You have nothing in that review material that you'd like to ask about?
No.
Okay. Well,
thank you.
I will talk to you. We're going to do 2 next week still? We're going to do Monday and Wednesday?
Yep.
Okay. Julie, I'll talk to you next Monday.
Okay.
Bye-bye.
Bye.